Good afternoon, students. Today we are going to learn hemoflagellates. Hemoflagellates are the protozoans that are present in the blood tissue of the humans. These are having single flagella and different types of morphological forms. They require more than one host to complete their life cycle. Hemoflagellates, and that we are going to learn Trypanosoma. As I already told you that these are protozoans. They belong to the kingdom Protista, phylum Sarcomastigophora, subphylum Mastigophora, class Zoomastigophora, family Trypanosomatidae, and genera is Trypanosoma. This was the classification. Next, we'll see the morphological characters of the hemoflagellates. All the hemoflagellates, they are going to have almost the same type of characteristics. Therefore, if you know the morphology of a hemoflagellate, most of the things you will understand. These hemoflagellates, they have single nucleus, and the nucleus is not always in the center. It is going to differ in the different morphological forms. Kinetoplast is a special structure that these hemoflagellates have. All are having single flagellum. This kinetoplast has got parabasal body and blepharoplast, which are closely related to this kinetoplast. And the morphological form of the parasite depends upon the location of the kinetoplast as in relation with the nucleus. Parabasal body, it is a part of the nucleus, and the parasite multiplies by longitudinal binary fission. When it multiplies, the first thing that multiplies is the kinetoplast. After the kinetoplast divides into two, the nucleus divides into two, the cytoplasm forms over the around this kinetoplast and the nucleus, and then the whole of the cell divides into two daughter cells. Blepharoplast or basal body, from where the flagellum arises, sometimes projects outside the cytoplasm and sometimes does not project. When the cytoplasm, when this blepharoplast or the basal body is inside the cytoplasm, it is known as the axoneme. Hemoflagellates, they are going to exist in four forms. These four morphological forms are amastigote, promastigote, epimastigote, and trypomastigote. These are the 4 forms. And all these 4 forms are being differentiated based on the size of the cell, shape of the cell, relation of the blepharoplast with the nucleus, presence of the flagellum, point of emergence of the flagellum from the cell, presence of undulating membrane. So depending on this, we can classify this hemoflagellates as amastigote, promastigote, epimastigote, and trypomastigote forms. Now here you can see in the picture, these forms are there. You can see that amastigote, which is a stumpy form, which is not going to divide, promastigote form, epimastigote, then metacyclic, and that's how it is going to go on changing in the 2 hosts, that is the definite host and the intermediate host. Now, amastigote is a oval in shape, measures 5 micrometers by 3 micrometers. The nucleus may be in the center or side of the wall. Kinetoplast is anterior to the cell. Axoneme is going to extend up to the anterior end. So this is the kinetoplast. This is the cell. The nucleus is at the side of the cell wall. Kinetoplast is in the anterior side. Axoneme is almost touching the cell wall in the anterior side. Promastigote is a long and slender one, 9 by 15 micrometers. Nucleus is centrally located. Kinetoplast is found at the anterior end and flagellum projects from the anterior end. It may have polyethylene granules. From here you can see this axoneme is inside, kinetoplast is there, polyethylene granules, nucleus, flagellum, flagellar pocket. This is how the presentation of the promastigote form is. Epimastigote is the 3rd form. It is long and wider. The size being 9 micrometers by 15 micrometers. Nucleus is located posterior to the midpoint of the cell. Kinetoplast is anterior to the nucleus. Flagellum emerges from the midpoint of the cell and it is going to run closely to the cell surface as a free web, and once it reaches the anterior end, it touches there, and this touching flagellum forms an undulating membrane which is going to contract and expand during its movements. Trypomastigote. It is long and wider, 12 to 35 micrometers in length, but the width is less, 2 to 4 micrometers. The nucleus is located almost in the center. Kinetoplast from anterior, it is shifting to posterior end of it. The flagellum also emerges near the posterior end of the cell and continues as a free web throughout the length of the cell and emerges out of the cell, out or is a free web and the cell, forming the flagellum. The flagellum, and from where it starts, that is the posterior end to the anterior end, it is going to have an whole length of undulating membrane. There is polyethylene granules present within the cell, and this is the metacyclic mastigote form, or it is also known as trypomastigote form. Trypanosoma species. The Trypanosoma species is divided especially into two, that is Trypanosoma brucei, gambians, and Trypanosoma brucei rhodescens. These two species, they are going to produce disease known as sleeping sickness, whereas Trypanosoma cruzi, it is going to produce Chagas disease. Now this Trypanosoma brucei, gambians, Trypanosoma brucei rhodescens, they are found in Africa, and the distribution of this parasite is quite different, and the disease that is seen is in the north part of Africa, whereas the Chagas disease is seen in the Central and South America. So you see that it is different geographical distribution where this parasite is seen. Gambians is seen in the western and central equatorial part of Africa, and Rhodians is seen in the east part of Africa. Sleeping sickness is also known as the African trypanosomiasis. Trypanosoma brucei gambins is found in the western and central part of equatorial Africa, and Trypanosoma brucei rhodescens is seen in East Africa and show this similar type of clinical presentation. Now we'll see Trypanosoma species. This parasite exists in two forms, that is trypomastigote and epimastigote. Now trypomastigotes show two morphological variations. Blood, lymph and tissue fluids, they will have the long slender forms which are multiplying by the binary longitudinal fission or longitudinal binary fission. This form survive in the vertebrates, and they are able to survive because of the ability to change the variant surface glycoprotein coat which is present on their cell wall. This variant surface glycoprotein is going to change every 8 to 10 days and evade the immune response. What does this mean? That is, this parasite, when it is going on multiplying, it will change the surface glycoprotein coat by which it is binding to the host. And if the host is taking some medicine to remove or to kill this parasite, the surface glycoprotein coat is going to change after 8 to 10 or after some multiplication cycles. That's why the parasite goes on multiplying in the host and does not go away from the host. Life cycle is complex. It requires two hosts. The definite host is vertebrate and humans. Trypanosoma gambians, that is the definite host is humans, and Trypanosoma rhodescens has two definite hosts, that is human and wild. The intermediate host is tsetse flies. T here is silent. That's why we pronounce it as tsetse flies. Reproduction is asexual and infective form is metacyclic trypomastigote. So when infective forms are introduced into the tissue of the definite host by bite of the tsetse fly, they get converted to trypomastigotes, which multiply locally in the blood. So whenever the tsetse fly is going to bite the human beings, through the bite or through the puncture of the wound that is there, this metacyclic trypomastigotes are going to enter into the human beings. And this trypomastigotes get converted to this metacyclic trypomastigote, which is the infective form. When they reach the blood or the tissue of the human beings, they will get converted to trypomastigote forms and starts multiplying. After some cycles of multiplication, this long, slender trypomastigotes get converted into short, non-stumpy, non-dividing forms. And when sucked, this is going to happen in the human being. Then, after that, this multiplying form or short stumpy forms, they are going to circulate in the blood of the human being. And when again a new tsetse fly bites the human being, this short, stumpy, non-dividing forms will enter into the tsetse fly. And this will reach the midgut. And once they reach the midgut of the tsetse fly, they will get converted into trypomastigotes and into the dividing form, and therefore there they are going to multiply. After multiplication, they will travel to the salivary glands of the tsetse fly and get converted into epimastigotes. This epimastigotes multiply and produce metacyclic mastigotes. Now this metacyclic trypomastigotes, they are the infective forms to the human beings. So this have to reach the human beings to complete the life cycle. Therefore, when the tsetse flies, they will bite the human being, then the life cycle gets completed. That is how it requires two hosts to complete its life cycle. In one host, that is from metacyclic trypomastigotes, when this tsetse fly, they are going to bite the human beings, they will get converted into trypomastigotes. They will multiply in the blood of the human being, and after some cycles, this trypomastigotes will, which are long and slender forms, they'll get converted into short, stumpy, non-dividing forms. And once they are in non-dividing form, they cannot cause any disease. And therefore, to complete the life cycle, they will have to be entering into the tsetse fly to complete this life cycle. So, from short, stumpy, non-dividing forms, when the tsetse fly bites the human beings, they will enter into the midgut of the tsetse fly, multiply there, and get converted into trypomastigote forms, and travel to the salivary glands, get converted to epimastigotes. Epimastigote forms will multiply and produce metacyclic trypomastigotes, and after they are reaching the definite host. How will they reach the definite host? The tsetse fly, when it has this metacyclic trypomastigotes in the salivary glands and goes and bites a new human being, this metacyclic trypomastigotes will enter into the new host, and then the life cycle continues. Pathogenesis. Red tender trypanosomal canker develops at the site of the bite in about 1 week. So, as you saw that when the tsetse fly, it is going to bite the human being, the infection will start, or the person will come to know after 1 week when there will be a canker that is formed, which is red in color at the site of the bite. The organism from there will invade from the site of the bite, will invade the blood, and goes this metacyclic trypomastigotes, they are going to get converted into metacyclic form. Say this. That is insect that is going to bite the intermediate insects, bite, that is, which is the intermediate host. From there, they are going to come as metacyclic trypomastigotes. They are introduced into the definite host. The trypomastigotes, they are going to be multiplied in the blood, and after a few cycles, non-dividing short stumpy forms are developing. The tsetse fly again bites this infected person, and this non-stumpy dividing goes into the midgut, multiplies there, and develops trypomastigotes form, which are the multiplying form, gets converted into the epimastigote forms. When they reach the salivary glands, they will multiply there and get converted into metacyclic trypomastigotes and reach the definite host, and that is how the life cycle will continue. Now, this parasitemia that is developing, that is whenever the parasite starts multiplying, then the person will suffer from parasitemia, and it is going to increase until a specific antibodies are produced in the body against these parasites, If antibodies are produced, then the canker gets healed. The antibodies, they will destroy the parasites. But as I told you earlier, that these parasites, they are having VSG, that is variant surface glycoprotein. So this will escape. That is, this new multiplied species or parasites, they will escape. And the older ones, which are having the older with the surface antigen, they will be killed. So a new wave of parasitemia will occur with this mutant VSG, and the fever will go on continuing for months together. Because of this, ability of the parasite to change the variant surface glycoprotein, even when the antibodies are formed in the body, few of the parasites will escape the destruction by the body and they starts multiplying. That's how parasitemia means constantly in the body and the person is going to develop fever. Central nervous system is invaded, producing leptomeningitis, Carandel's sign, which is positive, lymphadenopathy, that is Winterbottom sign, posterior cervical lymphadenopathy, splenomegaly, and anemia. Splenomegaly, because of the parasites that are killed, they are taken to the RBCs as well as the parasites which are destroyed, they'll go to the spleen, therefore there is splenomegaly developing. RBCs that are destructed, therefore anemia has been developed in that person. So, as I told you, trypanosoma, that canker, you can see here. Clinical features, because of the fever and all that is present because of the parasitic infection, there is persistent headache. The person is unable to concentrate. The personality of that patient is going to change. Daytime somnolence is developing, that is because of the weakness and because of anemia, because of the involvement of the central nervous system, the person feels sleepy. So even in the daytime, the person sleeps, developing sleeping sickness, CNS involved, therefore seizures, tremors, ataxia, neurological impairment, that is seen by the Winterbottom sign. The person can develop coma, and death also can occur due to the sleeping sickness. That will occur due to myocarditis with congestive cardiac failure and arrhythmias. This antigen of parasite has got some relation with the myocardial tissue. Therefore, it attacks or it is going to bind to the myocardium, and therefore inflammation of this myocardium occurs, leading to myocarditis. You can see this trypanosoma canker, Winterbottom sign. This is epilepsy. This is convulsion. So these are all the clinical features that are seen in this sleeping sickness. Lab diagnosis. Demonstration of the parasite can be done by wet stain preparations with Giemsa and right stain smears. So the blood examination, you take the blood, peripheral blood, and prepare this wet stain sign. So you will see that there is going to be this type of trypanosomas seen in trypomastigote forms that are seen in the microscopic examination. Concentration of the blood. So thick films can be done by taking the blood and centrifuging the blood, and this thick film you can find this type of parasites. The central nervous system is involved, therefore you can do CSF, that is cerebrospinal fluid can be taken and the parasite can be demonstrated. Isolation of the parasite can be done by inoculating in the animals. Treatment. In the early stages, suramin and pentamidine are the drug of choice. If CNS involvement is seen, melarsoprol is given, but this is highly toxic. So you can even give eflornithine, which is a less toxic drug, but its effectiveness is also not very good. But it can be administered because it is less toxic. Prevention. Avoiding areas harboring the tsetse flies. Using protective clothing. Use insect repellents. So this is what is trypanosoma or sleeping sickness. And why it is called sleeping sickness? Because the person, even during the day, even during the night, all the time the person feels sleepy because his immune system has been decreased, his immunity is decreased, he becomes anemic, he is having fever, CNS involvement is there, so there's no coordination between his body. All the systems are not being coordinated properly. So this type of disease known as sleeping sickness is going to be there. Any questions you can just ask on the WhatsApp.